All right, in this next section, we're going to review linear functions and some of their features to prepare us for the material for this course. So there are going to be several things that we're going to look at over the course of the semester in regards to functions. And this is to help prepare you for some of the fundamental concepts of calculus. In this section, we are going to introduce some of these key features, including where a function is positive, negative, or zero. And we also are going to look at where a function is increasing, decreasing, or constant. We're going to start by looking at linear functions, as those are the ones that we are most familiar with. We've been working with them for the longest amount of time. So hopefully all of this will kind of make sense as we go through it. Okay, so let's go ahead and start off with key features of linear functions. We're going to discuss several different forms in terms of linear functions, but the basic one that we all know is slope-intercept form. Slope-intercept form is y equals mx plus b, and note that we can either write it as y or we can also write it as f of x. We can use function notation for this. The y-intercept is represented by the number b, and if we want to write it in point form, the y-intercept is 0, b. This is where the graph intersects the y-axis. The y-intercept serves as the boundary between where x is positive, the right side of the graph, and x is negative, or the left side of the graph. So if we kind of draw this out a little bit, okay, what we have here is we have our coordinate axes, and it doesn't matter what kind of line we draw, but we have a y-intercept and it's somewhere on here. But the important thing is all of the points over here have positive x values, and all of the points that are on the left side of this line have negative x values, or x coordinates. And so this line right here, our y-axis, this is where y is 0, and 0 is neither positive nor negative, it's the boundary line. All right? Okay, now, some other things that we have. We have the slope is represented by the number m. And this number m does a couple different things. And this is going to be one of the things that we're going to kind of introduce and play around with a lot over the course of this semester. We have 4 possibilities for m, and the first 3 are the ones that we really want to focus on. But we have m can be greater than 0. What this means is it has a positive slope. And the word positive, what it equates to is it is increasing from left to right. So if we draw this out, what we have here is we have a line something like this. And keep in mind, all we care about is it goes up from left to right. Okay, that's our first one. We are going to be coming back to these terms of increasing, decreasing, and constant again, so we want to kind of have a general idea of what this looks like. Okay, the next one that we have is m can be less than 0. And in this case, it has a negative slope. And what this equates to is a decreasing line. And so a decreasing line from left to right means that we go down from left to right. And the last one that we really care about for this class is we have m equals 0. And so, well, it's called a zero slope. And what we have is the line is horizontal. This is our constant function, or we have our line is constant from left to right. It does not change. And so when we draw this, what we have is a horizontal line. We have a flat line. And so it's going to look like this. These are the three that we do want to focus on because we are going to be working with these throughout this module and in the future modules as well. Now, in terms of lines, we do have one more that we want to talk about, and that is we've got our positive, negative, and 0. The last one that we have is if m is undefined. Okay, this only happens with linear functions. And so if it is undefined, we say, okay, it has an undefined slope, and the line is vertical. Now, the reason that we're not going to worry about this so much is that this is not a function. Okay, and this one has one x value and a lot of y values. And so this is an undefined slope. It is a vertical line. And because it does not satisfy the conditions for function, well, it's not a function. Okay. The way that I kind of keep track of the m equals 0 and the m is undefined is, can you walk on the floor, which is flat? And the answer is yes. And undefined, can you walk up the wall? And since none of us are Spider-Man, we can't walk up the walls. We can maybe get a couple steps up there, but we're going to fall down. Okay. All right, the last thing that we have is, let's finish up with slope. Our formula, we are going to be playing around with our formula for slope. And formula for slope, the first thing that we need to be given is 2 points. Remember, points are always x comma y. And what we do is we label them x1, y1, and x2, y2. To figure out the slope, what we want to do is we want the change in y, that is y2 minus y1, over the change in x, which is x2 minus x1. Doesn't matter what order you plug these into your formula, as long as you are consistent in terms of whatever you do on the top, whatever order you do it on the top, you have to do it on the bottom. All right, a couple more things before we get into our examples. So we talked about y-intercept, we talked about slope, and the last thing that linear equations have is x-intercepts. And so the x-intercept can be found by setting y equal to 0 and solving for x. The x-intercept is of the form, if it's in point form, it is k comma 0. Notice here that we have a value for x, something, it can be anything, but our y value is always 0. And this is where the graph intersects the x-axis. The x-intercept serves as the boundary between where y is positive above the x-axis and where y is negative or below the x-axis. And the x-coordinate of the x-intercept is the value where the function or equation is equal to 0. Okay, so just so that we kind of can visualize this a little bit, just like with what we did with our y-intercept, we're going to do kind of the same thing with our x-intercept. And this is one that we do care about. We're going to play around with this quite a bit in this module and the next one. So when we look at our x-intercepts are on the x-axis, so all of these. Remember, they all have a y-coordinate of 0. If we are above the x-axis, then we have y is greater than 0, or y is positive. And if we are below the x-axis, then we have y is negative. And the boundary line is where y is 0, where it is neither positive nor negative. Okay, so we're going to play around with that in this section, and we're going to see it again later on. Okay, so when we are looking for things, some of the things we're going to be talking about is we want to be able to find where a graph is positive, negative, increasing, decreasing, or constant. We are going to have to use open intervals, no square brackets, for definitely the increasing, decreasing, and constant. And quite often we're going to use them for the positive and negative. And the reason is because, let's talk about positive and negative just a minute. Okay, if we're below the x-axis, we're negative. If we're on the x-axis, we're 0, and we cannot be two things at the same time. Okay, and so same thing with positive. If we're above the x-axis, we're positive. If we're on the x-axis, we're not positive. And so we want to make sure that we use those boundary points. And the x-axis is that boundary line that changes between positive and negative. We cannot include that boundary line because it is not positive or negative. It is 0. The main thing, so that's one of the reasons why we're not going to use square brackets. Now, the other thing that we want to keep in mind is when we look for positive, negative, increasing, decreasing, or constant, the y-coordinates determine whether it satisfies the condition, but we use the x-coordinates to answer the question. These are the input values that create the conditions that we are trying to satisfy. So for instance, when I ask, or when we're being asked, where is the function positive? Where is it above the x-axis? The y values tell us when it is, but the numbers that we are inputting, those are the ones that we want to answer with. We are saying that when x is this, y is positive. All right, that's enough of that. Okay, so we're going to be playing around with this a lot this semester. So if it takes you a little while, that's okay. Okay? All right, we're going to start with looking at some linear equations in order to get us started. These are the easiest ones to work with. And so what we're going to do is we're going to graph these equations, and we want to identify the following. So we first want to know what is the slope. So we have an equation, f of x equals 2x minus 6. This is in slope-intercept form. And so my slope is the 2. Okay, I want to know, is the line increasing, decreasing, or constant? Well, because our slope is positive, it is increasing. Just a reminder, increasing means that we are going up from left to right. Okay, we want to know what is the y-intercept. The y-intercept is that second number, and so it is going to be the -6. And if we want it in point form, remember this is the y-coordinate, it is -6, and the x-coordinate is going to be 0. The x-intercept, we can do a couple different things to find this. One of the first things that we can do is remember that x-intercept, this means y equals 0. And so if we plug in 0 for y or for the f of x, we can then solve for x. So we can add 3 to both sides. Add 6 to both sides. And then we can divide by 2. And we get that the x-intercept is 3. Remember, this is an x value. It says x equals 3, so we plug that in for x, and my y was 0. Okay, now let's go ahead and graph this. So we can do a couple different things. Okay, we have, we can graph using slope and y-intercept. And if we do that, we are going to get that our y-intercept is 0, -6. So starting at the origin, I want to go down 6, 1, 2, 3, 4, 5, 6. We're going to be down here on the bottom line. And then I want to use my slope. My slope, this is 2 over 1, which means I want to go up 2 and right 1. And so if we do that, we get up 2, right 1, up 2, right 1, up 2, right 1. Notice I'm crossing my x-axis at 3, 0. And so this is our line. All right. We also want to know where is the function equal to 0. So where is the y? 0. Remember that equal to 0 means where is 2x minus 6 equal to 0. And so that is my x-intercept. Remember that we are not going to answer in terms of points. This is going to be when x equals 3, the function equals 0. We want to know where is it positive. Remember that in order for my function to be positive, we want to know where is y positive. We want to know where is y above the x-axis. And so this is going to be an interval. So this is going to be from 3 to positive infinity. We do have a parenthesis around the infinity, and we also need a parenthesis around the 3 because at 3 it's equal to 0, which is not positive. The last thing that we want is we want to know where is it negative. We want to know where is it below the x-axis. And so it is below the x-axis. We have our arrow down here that goes forever down and goes forever to the left. So that is going to be from negative infinity. And it is below the x-axis, starting way over here, and we keep going until we get to where it's equal to 0 again. And so it's going to be from negative infinity to 3, and again, we want a parenthesis because being equal to 0 is not the same thing as being negative. Now, if you notice, one of these we have one answer, and other ones we have interval notation. Well, why is that? Well, when you're equal to 0, that is just one value. On the other hand, positive, lots of numbers are positive. Everything above the x-axis is positive, and so that's going to have to be more values. We do not list them out because, for instance, we could say 4, 5, 6. We could do all these, but the problem is we also have all of these little values in between the nice numbers that we have to include them as well. And remember, as I said when we talked about classifying numbers, we can't list them all out, and so that is why we use interval notation. All right, so now we have an idea of an increasing line. We can see where the y-intercept and the x-intercept are, and we have an example of positive, negative here. All right, let's look at our second example of a linear function. Okay, so the first couple questions, we're still going to be asked the same couple things. We want to know what is the slope, and so remember that our slope is the number in front of the x, and so for this one, we have a slope of negative 2/3. Now, by looking at that slope, we want to determine if the line is increasing, decreasing, or constant. And here, because the slope is negative, it is going to be a decreasing line. So it is decreasing. The slope is negative. And just a reminder, what this means is decreasing goes down from left to right. Okay, we want to know what is the y-intercept. Our y-intercept is the other number, and so it is going to be the negative 2. And remember that we do want this in point form. And so the negative 2 is the y value, and when we're talking about the y-intercept, that means that our x is 0. All right, the next thing we want is the x-intercept. You can solve for this the way that we did previously, or we can actually try to see if we can find it graphically. And so if we go ahead and graph what we know right now, we do have our y-intercept is 0, negative 2. We have our slope is negative 2 over 3. So what this means is we can do this one of two things. You can go down 2 and right 3. Or you can also think of this as 2 over negative 3, which tells me I want to go up 2 and left 3. As long as we just have a negative in here somewhere, it doesn't matter where. So if we look at it this way, if we go up 2 and left 3, we're going to end up over here. If you had decided to go the other direction, that is fine in terms of finding the line. If we go down 2 and right 3, we're over here. And the only reason I wanted to go the other direction was because when I saw which direction I was going, it showed me that I was getting further away from my x-axis. All right, so we have our line, we have our points, we're going to connect the dots, and we've got our line. And so if we look at this, we want to know, remember the goal was what was the x-intercept. And so our x-intercept is this point right here. And so our x-intercept is -3. And when x is -3, y is 0. All right, so the next thing that we want is we want to figure out where is it equal to 0, where is it positive, and where is it negative. Okay, so we know where it's equal to 0. This is our x-intercept. And so we are equal to 0 when x is equal to -3. Where are we positive? Where are we above the x-axis? Well, this is to the left of -3. We want to think from left to right. Remember that our interval notation is always left to right. So this arrow goes forever to the left, which means that this is going to be -infinity. And we are above the x-axis until we get to -3. Remember, we do not want to include -3. We want a parenthesis around that because 0 is not positive. All right, we want to know where is it negative or where is it below the x-axis. And so we are below the x-axis when our x values are to the right of -3. And so we are negative, starting at -3, not included again, going towards positive infinity. All right, that is example B, equal to 3. All right, the last example that we want to look at is f of x equals 3. Now, for this problem, notice that we have no x in our equation, which means that our slope is 0. There are 0 x's. And so that's what we have for the first part, m equals 0. Well, since m equals 0, that means it's not increasing, because remember, increasing is positive. It's not decreasing, because decreasing means it's negative, which means that leaves us with our final option, that this is constant. Since our slope is 0, it is a horizontal line. This is a flat line, which means it's just constant. It stays at the same level. It doesn't go up or down. We want to know what is the y-intercept, and the y-intercept is going to be 3. So remember, here we have when if we could plug it in. If we plug in 0 for x inside the parentheses, well, what's the equation equal to? Well, it's equal to 3. Since y is always equal to 3, it's never going to equal 0. Remember, that's how we find x-intercept. We set y equal to 0 and solve for x. But y is equal to 3, it's never 0, and so for this one, we have no x-intercepts. All right, if we graph this, we have y equals 3, we have a y-intercept is 0, 3, and we just need to pick at least one more point in order to graph this. And it doesn't matter what we plug in for x, we have y is and so this is what our equation looks like. All right, where is the function equal to 0? Where is it on the x-axis? It's never equal to 0, so we say not applicable. We want to know where is it positive? Where is it above the x-axis? And well, since this line is always at 3, and 3 is always positive, then what we have is -infinity to infinity. No matter what value we plug in for x, it's equal to 3, and 3 is always positive. We also want to know where it is negative, and because this is never below the x-axis, then we also have not applicable for this one. Now, we've talked about 3 types of lines, and we've talked about increasing, decreasing, and constant. Now, for linear equations, the entire thing is either going to be increasing, decreasing, or constant. It either goes up forever from left to right, it goes down forever from left to right, or it stays at the same number from left to right for all values of x, and that's one of the special things about linear equations. Now, as we move forward in this class, we're going to be extending these concepts and to other types of equations. And when we talk about increasing, we want to think about going up, and decreasing, going down, and constant, staying flat. And these are going to be applied to further examples. All right, the last thing that I want to look at for this section is we're going to look at an application problem. For this, we want to talk about interpreting the slope. And so in order to interpret the slope, we do need to do 2 things. The first thing that we need to do is we need to identify whether the slope is increasing or decreasing. We also want to use words that represent increasing or decreasing. The second thing that we need when we interpret slope in the context of application problems is we do need units. And because slope, if you recall from last semester, slope is a rate of change, keyword being rate. We want to identify the units for the change in the y, or our dependent variable, and the change in the x, the independent variable. Those are going to be the 3 things that we need in order to interpret a slope. All right, so let's go ahead and see what we can do here. We have the distance d in miles that a train is from a station after x hours is given by the formula d of x equals 150 minus 20x. So the first thing we want to know is, okay, what is our slope? Remember that the slope is the number with the x, and what we have here is we have that it's negative 20. That's our slope. Now we do want to interpret it. And so we want to say that the distance is decreasing. Why decreasing? Because it's a negative. And then we want to say by how much. So we have our number part. It is by 20. And we do need to include our 2 units. So our units for the dependent variable, which is our distance, is going to be miles. And then we need the units for the x, which is hours. And so here we have the distance is decreasing by 20 miles per hour. We have the 3 things that we need. We have our decreasing, and then we have our 2 units, miles per hour. We can also interpret other things. So for instance, we want our y-intercept. And so our y-intercept, this is our b value, which is 150. And we want to interpret it. So let's go back and read the sentence again. It says the distance in miles that a train is from a station after X hours is given by this formula. So when we talk about the y-intercept, what we're talking about is the initial value when x is equal to 0. So when we interpret the y-intercept, we want to use phrases like the train started at 150 miles And here, this is from the station. So we kind of want to take these keywords that we have in here. Notice here that X hours, this is our starting. We have that, what does this represent? This is the distance from the station. And so that's all we need to include when we interpret this. Now we can interpret the y-intercept, but we can also interpret other numbers. And so for instance, for C, we want to calculate and interpret D5. So the first thing we want to do is we want to plug in 5 into our equation. We get 150 minus 20 times 5. We simplify this. We get 150 minus 100, and this is equal to 50. All right, so now we want to interpret this. So what this means, remember, 5 was our X value. So after, we're going to use this word up here, after 5 hours, the train is 50 miles from the station. This is another thing that we're going to be doing quite a bit in this class, is talking about interpreting word problems. And we want to always be aware of what it is that we're looking at. Notice on all of these, when we talk about points, this is distance at a certain time. The only one that has to have 2 units is when we interpret the slope, because we do need to use both units, as slope is a rate. All right, that's the first part of this video. I will see you in the next one.